Okay, this LOS is calculate and interpret the future value and present value of a single sum of money, an ordinary annuity, annuity due, a perpetuity, and a series of unequal cash flows. So this is perhaps one of the longest videos for an LOS. I have about 28 slides because this is time value of money 101. So there's some basics with regards to the algebra, and there's some learnings that we need to do with the calculator. So the first part is the future value of a single cash flow. So of course we've got the algebra formula. The future value equals the present value times 1 plus I, or we see R sometimes, the interest rate, to the n, the number of years, okay? For now we're just keeping it simple. We're using whole years. So suppose you win 3 million euros and you invest it for 7 years at 3%. Okay, so we could do it with the algebra. It would be 1.03 y to the x 7 years, okay, times by my 3 million, and I would have 3.689621 euros at the end of 7 years, okay? So we can also do this on the financial calculator. We can do second, just check our PY is still set at 1. We could do 3 million euros. Sorry, 1 0 too many. And that's money out of our pocket that we're going to invest, so make it a negative. 0 payments, and we're going to get 3 IOI, and it's for 7 years. Compute the future value. Aha, going to get the same number. You can see 3,689,621. So for me, throughout the CFA, I was very keen on always using the time value of money functionality. You know, the algebra is nice to know, but I think it's better to know how to use the calculator. And then finally, for my students, I call this the beginner way. You know that you're going to earn 3%, and it's going to be every year for 7 years. So it's not 20. You can do 3 million times 1, 2, 3, 4, 5, 6, 7, and you'll get the same answer. That's the, you know, you don't have a financial calculator. 3 million times 1.03 times 1.03, that's 2, times 1.033 times 1.034 times 1.035 times 1.036 times 1.037, and I'm going to get the exact same number, 3,689,621. So that's just a little bit to make you laugh. That's for the non-math lovers. 1, you've got the algebra. 2, you've got the financial calculator. 3, you've got the very beginner way. Okay, I know I did that time value of money functionality a little bit quickly, and some people might be looking at this video using a financial calculator for the first time, so I'm just going to slow it down and walk you through it a little bit. So you can see the keys here. This is the time value of money keys. We have the N, the IOI, interest rate per year, the present value, the payment, and the future value. So all these CFA type questions, there's 5 variables. Given 4, you have to solve for the 5th, you know? And so you might be solving for the number of periods, what the interest rate is, what the present value is. We do that for the price of bonds. What the payment is, what the future value is. And then there can be a little bit of complexity. You know, when we get into the annuities, the payment can be at the beginning of the period or at the end of the period. So we'll adjust some parameters. And as we've already seen in some previous LOSs, we get into payments being not only annual, but semi-annual, quarterly, etc. So we have to change also some parameters like our periods per year, okay? But just in general, so when we're talking about the future value and the present value, one of these must be negative. So that's why you'll hear me say from time to time, oh, money out of my pocket is negative. Oh, money coming in is positive. Because if you're solving, for example, for an N, and you make both the present value and the future positive, you're going to get an error message. It's not going to work, okay? So FV is the future value, PV is the present value, payment is if there's any periodic payments, IY is the period interest rate, N is the number of periods. Now I know you can solve things two ways on the calculator. Some students don't like to change the parameters, second PY, and then they'll adjust their interest rate. But I don't recommend that. I always recommend setting up the parameters properly, and therefore you don't have to make any adjustments to your answer, any adjustments with your inputs. Okay? So again, those are the keystrokes, that the important keys that you need, and we'll walk through some problems and increase your familiarity with the financial calculator. So this slide again was just giving you some tips on how to use the calculator. So this one, if it's annual payments, you have to be sure that the payment per period is set to 1. So how do you do that? It says press the second key, press the periods per year that's above the IY, enter 1, press enter, and press second or quit clear. So let's just, we've already seen that in previous LOSs when we're doing things at different frequencies of compounding. Nevertheless, quick review. Second IY, so here it's set at 1. If it was semi-annual like a bond, we'd hit 2 and then enter and just hit clear. Okay, so again I'm going to check second PY. Oh, I had it set as semi-annual for a bond, previous question. Hit 1, this one is annual now, enter, and then clear. So that's setting up parameters on the calculator. Okay, this slide is just showing you how to set up the ending or beginning. If cash flows are at the end of the period, you need to be in the ending mode. So how do you switch the calculator from beginning to end? It's just here, it's above the payment key. You do second, beginning, second enter. I'm going to get my little beginning symbol, and then you hit clear. You can see now I've got it in my beginning mode. Sometimes that's important for some annuities. They tell you the payments at the beginning and the period beginning. You need to be in the beginning mode. Then you go on to the next question. No, it doesn't. It's not in the beginning mode. You need to change it. So second, beginning, second, enter, hit clear. The begin is not there, so we're fine. So there's the keystrokes. Press the second key, press the beginning mode. This is a toggle switch. The default is end when you get the calculator. To change it to begin, that's how you do it. Should be no problems with that. So again, that's just going through that same little question that we saw. Present value is $3 million, you want it, and you're going to invest it for 7 years. You don't need the money, and you're going to earn 3% interest compounded annually. So again, just check, better safe than sorry. Check my periods per year, it's 1. So how do we do that? I usually start from the left and work my way right. So it's 7N, okay, it's 3 IY, and you can see enter is a whole number, there's no percentages there. It's 3 million that you got, and it's going to be money out of your pocket. You're going to invest it, so I make that a negative present value. You're not going to make or receive any payments to the end, and you hit compute the future value, and there you go, the 3,689,621.596. So as I said, note that for an investment we consider that to be cash out, so we use the negative sign. Okay, this slide is talking about annuities, and what is annuity? It's a series of cash flows. So annuity is a finite set of sequential cash flows. So that means, X amount of dollars for X amount of years. It's finite. An ordinary annuity has the first cash flow 1 period for now. So it's at the end. It's at the end of, it's at the end of the year. We're at time 0 right now. It's at the end of the year, ordinary annuity. Annuity due means that the payment comes immediately. It comes now at time 0. So ordinary annuity, end mode. Annuity due, beginning mode. It happens right now. A perpetuity is a perpetual annuity, a set of never-ending sequential cash flows with the first cash flow 1 period from now. So as I'd already mentioned, in an ordinary annuity, we're going to have the calculator in the end mode because the payments are coming at the end of the period. But for an annuity due, they're coming at the beginning of the period. So you can see I put here the calculator should be in the beginning mode. Again, many times, second, begin, second, enter, clear, I'm in the beginning mode. Okay, now we're going to look at the future value of equal cash flows. We're going to call that an ordinary annuity because it's a series of cash flows, okay? In this question or example, we're going to make a payment of $1,000 a year at the end of every year. We're going to do that for 5 years, and we're going to receive an interest rate of 5%, and we want to know how much we're going to have in the future. It's a future value. So if I drew a little timeline, time 0, there's nothing, no value there, then money's going to go out year 1, year 2, year 3, year 4, and at the end of year 5, how much am I going to have? So I need to be in the ending mode, which I am, and I'm going to check my PY again, second PY, yeah, 0 is very good. So I usually work from the left to right, so it's going to be 5N, 5 years, 5 IY, there's no present value, the 1,000 payment is out of my pocket, so I make that 1,000 negative, and that's a payment, and I simply hit compute the future value, and I've got 5,525 and 63 cents. Okay. Okay, this is a nice little practice exercise. Actually, on the CFA level 3 in the essay question, this is the exact type of question calculations you need to do. You have a scenario of either an individual or a family or a foundation, and there's kind of an entire wealth management, financial planning type recommendation that you need to make. So you need to know what are the requirements that the individuals need, how much do you need to invest, for how long, what are the rates, etc. So this is very typical of some basic calculations you need to know. So this scenario is your company's defined contribution retirement plan allows you to invest up to 20,000 euros per year. So you plan to invest that 20,000 in a stock index fund for the next 30 years. So historically, on average, that is earned 9% per year. So assuming that you actually earn 9%, how much money will you have available after making the last payment? So a key thing here doesn't say you're making payments at the beginning of the year. I found that with the CFA, if it doesn't specifically mention the beginning of the year, then you would assume it's at the end of the year. So my calculator is in the ending mode, okay? So again, just better safe than sorry. I'm going to check my calculator. Second PY, yeah, I'm in 1, annual payments, and I'm in the ending mode. So starting from left to right, it's going to be 30N for 30 years, it says. I plan to invest for 30 years. And the interest rate is 9% return on average long-term to the stocks. No present value. I'm just starting my payments now. And as I said, it's going to be 20,000. That's out of my pocket that I'm investing in the fund. So I make that a negative, and that's my payment. And I'm simply going to compute then the future value. And I'm going to have 2,726,000 euros, 150. So that's pretty nice. Almost 3 million. That's the power of compounding at 9% for 30 years. Again, here's just a slide in case that's a little bit too quick for you, because I know some people may just be learning the financial calculator for the first time. They want to see it a little bit more slowly. So again, we're going to calculate the present value, 3%, 7 years. It's the future value is 3 million. So again, I haven't been doing it that often because I always inputting to all 5 keys, but you can do second, clear the time value money of work. Second, clear the time value of money of work. Second, clear, and it'll delete all your inputs. But I'm always overriding everything, so I rarely clear the time value. But anyhow, so again, if I want to do left to right this time, it's 7N, and it's 3 IY, and there's no payment, and the future value is that 3 million that's going to come in the future. So I'm going to compute the present value, and there I've got it, 2,439,274. Okay. Okay, this slide is just a little bit about financial dynamics. So it says for the longer time period, the higher the future value, of course, because you've got more time for it to be compounding, to be growing. And likewise, the longer time period, the lower the present value, because you've got more time that you're discounting it back. And then the higher the interest rate, the larger the future value, of course. If I have $100 and I invested at 10%, it's going to be worth more than if I invested at 5%. And then likewise, the higher the interest rate, the lower my present value. Now you got to be very careful, because that's a rule in general, but when we start to look at uneven cash flows, and you've got a negative cash flow at the beginning and a negative cash flow sometime in a subsequent period, these principles do not apply if you have uneven cash flows and you've got negative cash flows subsequently after the first initial cash flow. And that's a bit of a trick question that we see in the corporate finance section. Okay, this one should be easy. Now we're looking at an ordinary annuity, which is a series of cash flows again, but now we're looking at the present value. So this is $1,000 payments occur to you at the end of each period. So that's an ordinary annuity for 5 years. What's the value of that to you today? Okay. So again, I said here, payments to you are cash inflows. Therefore, we can use a positive sign. So again, I'm just going to check my periods per one because it says annual. So we know there's no future value in this. The payments to you is $1,000. So that's a positive to you payment. And the interest rate is, well, in this case, it's 12%. So 12 IY, and it's for 5 years again, 5N. And we're going to compute the present value. And that is worth to me $3,604.77. That's the equivalent if I had money today, or versus a $1,000 payments to me at the end of each period for 5 years, the interest rate at 12%. Okay, here's a nice little practice problem. It says you're retiring today. You must choose to take your retirement benefits either as a lump sum or as an annuity. So your company's benefit officer presents you with two alternatives: immediate lump sum of $2 million or an annuity with 20 payments of $200,000 a year with the first payment starting today. Aha, starting today, so that's annuity due. The payment starts immediately at time 0. So the interest rate at your bank is 7% per year, compounded annually. Which of the option has the greatest present value? So we know the $2 million given you today, the present value is $2 million. There's no calculations that you need to do. So you need to check what the value of that annuity due is. So that's, it's a beginning mode, annuity due. So I have to change second begin, second enter. I'm going to clear that up. Now I'm going to enter my data. If I go from left to right, it's 20 years, 20N. The bank interest rate is 7%. And I'm going to be calculating the present value. The payments to me is $200,000 a year. And that's going to be payment in, so I can use the positive sign. And they're going to stop after 20 years, so there's no future value. So I'm going to compute the present value, and I see it's $2,267,119, which is more than the $2 million. So if I think that I can get 7% per year compounded annually, then I would choose to take the annuity because it is worth more in present value terms than the lump sum. So a quick little practice question for you. At a 5% interest rate compounded annually, the present value of a 10-year ordinary annuity with annual payments of $2,000 is $15,443. The present value of a 10-year annuity due with the same interest rate and payments is closest to what? $14,708, $16,216, or C, $17,443. So it's asking you to calculate the present value of annuity due. Okay, I'd say this type of question is more typical of what you'd expect to find in terms of the level of difficulty on a CFA exam, because it's kind of a two-part problem again. So a 24-year-old is using the following information. She's planning her retirement. So she's 24 years old. She's expecting to retire at 68 years old. She has a life expectancy to 93. Her annual expenditures currently are $30,000. The expected inflation rate of current expenditures is 3%, and the return on investments is 8%. So they're giving you a lot of data, time value of money, and timeline related. And so you need to be pretty quick on these. So she assumes her consumption expenditures will increase at the rate of inflation 3% until she retires. Upon retiring, she'll have end-of-year expenditures equal to her consumption expenditures at age 68. The minimum amount that she must accumulate by age 68 in order to fund her retirement is closest to A, $928,000, B, $1,176,000, or C, $1,552,000. Okay, this is a nice little two-part problem that's more typical of the type of question you'd see on a CFA exam. So you can see she's currently 24 years old. She plans to retire in 68 years. So that's 44 years from now, 68 minus 24, okay? And then she plans to be retired until 93. So 93 minus 68, that's going to equal 25 years. Plans to have a 25-year retirement. So currently her annual expenditures are $30,000, and they're expected to grow at the rate of inflation 3% for the next 44 years. Then that's the amount that she wants for her 25-year, to be able to for the 25 years of her retirement. She wants to have that level of expenditure. So we need to know how much money does she need when she's going to retire. Okay, so let's solve the first part. So we know the N is going to be 44. So she has 44 years until she retires. It's 3% inflation rate. The 30,000 is the current consumption, present value. No payments. It's not annual. It's not a series of payments. So we're going to compute the future value, and we're going to get 110,000. So 44 years from now, that 30,000 is the same as 110,143 at her retirement date. Now she wants that level of spending at the end of every year for 25 years. So now it becomes a second part of the time value money. So you can see that she wants that as her payment, and the N is 25, and the interest rate, the return on the investment changes. It's 8%, so you need to be careful there. It's not the 3%. We need that extra data. Okay, so I can just clear that, and I can make that my payment. Okay, and there's going to be 0 future value because that's the end of the retirement, and we have 8 IY, and it's for 25 years retirement. So we want to calculate what the present value of that is, and that's 1,175,757. So that again is closest to B. So the correct answer is B on that. Okay, and so that's a two-part question. You have to be a little bit quick calculating the number of years from her age now to when she wants to retire. She has consumption now, expenditures, needs to grow by the rate of inflation. That's how much money she wants per year, every year for 25 years. So that's a payment to her. And so you need to calculate how much does she have to have as a lump sum to be able to afford that type of annuity. So a good little question, excellent little practice. This slide is really quick. It's the present value of an infinite series of equal cash flows. So we just have a formula here. The present value equals the amount of the payment divided by the interest rate. Okay, so this, the British government once issued a type of security called a consul bond, and it promised to pay a level cash flow indefinitely. So if the consul bond paid £100 in perpetuity, what would it be worth if the required rate of return was 5%? So that's really easy. You just take your 100 and you divide by your 0.05, and the value of that's £2,000. Anyhow, a quick little practice problem for you. Sweepstakes winner may select a perpetuity of $2,000 a month, beginning with the first payment in 1 month, or an immediate lump sum of $350,000. If the discount rate is 6% compounded monthly, a little bit different here, the present value of the perpetuity is less than the lump sum, equal to the lump sum, or greater than the lump sum. So here we have to calculate the present value of a perpetuity. $2,000 a month, $6,000 monthly. Okay, just a little twist to that question because it's $2,000 a month and it's 6% compounded monthly. So if we look at the solution to that, the payment is $2,000, no problem with that. But then our interest rate, it's 6% divided by 12, which is 0.005. So if we did the 2,000 divided by 0.005, it's going to give us £400,000, which is greater than the lump sum. So the correct answer is C. Okay, just going to do a couple of quick questions, solving for the interest rates or growth rates. So the IOI is can be thought of as a growth rate. So here's a little scenario. Hyundai Steel, the first Korean steel maker, established in 1953. So sales increased from 10,503 billion won to 14,146 billion won in 2008 to 2012. So that would have been 2009, because it's the end of 2008, 2010, 2011, and 2012, the end of 2012. So that's going to be 4 years, first of all. Okay, that's important. And so it says here, calculate the sales growth rate. So that's not too difficult. We have 4N. We have a present value of 14,164. Sorry, that's a future value. Make that positive. So we know there's no payments, 0 payment. 1 has to be negative, so this is the key thing. So we're going to do 10,503 is the negative present value, and then we need to compute the IY, and we get a rate of 7.7262. Or for those of you that like the compounded annual average growth rate, you know that you could do the 14,146 over the 10,503 to the power of 1/4 minus 1. Okay, you just have to make sure, because it says in 2008, so that's the end of 2008, and it's the end of 2012, so that would have been 2009, 10, 11, 12. As long as you got the n equals 4 right, you're going to be okay on that question, or that type of scenario. And don't forget how to calculate the compounded annual average growth rate. That comes up sometimes in different types of questions. Old school is good school. You know, they'll give you, this comes up later on when you need to calculate some growth rates. And they're going to give you, you know, a value at one point in time and a value at another point in time. And either use the financial calculator or use your compounded annual average growth rate. Either way, that'll give you they give you the G, you know, the growth rate. So this one is just a little bit of practice on the asking you to calculate the profit growth rate, and you can see it tells you that profit declined. So we know that it's going to be negative. So again, it just went through. I won't go through it. This is just very quick. 4N. You had the present value, you had a future value which was less, and you compute the IY, it's going to give you a negative. Well, maybe we'll just do it for fun. So let's do 4N, and present value was 822.5. We'll make that a negative present value. 0 payment. The future value was less. It was 796.4. That's going to be a positive. So we're going to compute the IY, negative 0.80293. And as well, I said over here, you could still use the compounded annual average growth rate, ending divided by the beginning to the 1/4 minus 1. And so it's 0.89, sorry, 0.80. So we know it declined, it's negative. Okay, we're almost done, folks. We're down to the last 4 slides, and this is definitely my longest training vid ever, but mini vid, but there's been a lot here because this is kind of the foundation. So this one is solving for the number of periods, so we're going to be solving for n in this case. So you're interested in determining how long it will take for an investment of 10 million euros to double in value. The current interest rate is 7% compounded annually. How many years will it take to double to the 20,000? So again, we can just use our time value of money. We're going to check that our second PY is set as 1, and our negative, our present value is 10 million, so I'm going to make that a negative. Negative 10 million present value, and it needs to double, so that's going to be 20 million future value, and there's no payment, and it says the interest rate is 7%, so that's 7 IY, and then simply we just compute for n, and we're going to get 10.24477 years. So very easy. Again, as I said, given it's always 5 variables. Given 4, you need to solve for the 5th. Okay. Now some of you may have learned how to do that using the present value tables. You would do 20 million divided by the 10 million, and then you would go to the 7% table, and then scroll down until you found the number of years. But they don't give you any tables on the CFA exam. You got to use the financial calculator. no problems. Okay, here's a nice little question. It's for a lump sum investment of 250,000 yen, invest at 3% compounded daily. The number of months needed to grow the sum to 1 million yen is closest to 555 months, 563 months, or 576 months. So a little bit of a twist on a question, but again, read carefully and work through the steps. It should be no problem. See, this one's a little bit tricky the first time you do it because it's giving you 3% compounded daily, okay? So let's just go through it. We're going to check our second PY. It's going to be 365 because that's daily. We're solving for N. So it says 3%, 3 IY, and our present value is that 250,000 yen is going to go out of our pockets. So that's a negative investment, okay? There's going to be no payments, and we have a future value of 1 million yen that we want, okay? So we're going to compute N. Aha! This looks a little bit confusing. We got N equals 16,867.27, but N is our number of periods, not the number of years in this case, okay? Remember? So we know that that's the number of days. So we're going to divide by 365. So when we divide that by 365, we're going to get 46.21 years. And it's asking us for months, okay? So we need to multiply 46 times 12, first of all, and then 0.21 times 12, okay? So let's just clear that. 46 times 12 is going to be 552 months. So it's the 552, but then we've got to add the 0.21 times by 12, and that gives us another 2.52 plus 2.52. So add that to my 552, and sorry, I went too far, 552, and I'm going to have 554. So the correct answer is A. So that's a funny little one, and that's why the more I always say you got to practice as many problems as possible, because the first time you see something, you get a little bit confused. You know, fool me once, shame on you. Fool me twice, shame on me. You won't get fooled again. Finally, our last slide, and this is a good one because we're solving for the payments in this case, and this is a very popular one. You want to know what your mortgage payment is or what the payment car payment is. So it's for the size of the payments. So you're planning to purchase a $120,000 house by making a down payment of $20,000. Aha! That means you're borrowing $100,000. Be careful with that. And the remainder is going to be a 30-year fixed rate mortgage, monthly payments. Aha! So that's PY is going to be set to 12 and is going to be 30 years times the 12, okay? And the interest rates are 8% monthly compounding. So what will your monthly mortgage payments be? That's a very popular type of question, not only in on the exam, but in real life as well. So let's do that one. We're going to do second PY. Aha, I had it on daily from the last question, so I got to change that to 12. I'm going to hit enter, so I'm on my monthly now. The N, again, I can, I've set my parameter, so it's 30 years. I can do 30 second NN, so it's 360, or you can do 30 times 12 and enter the 360. 8 is the interest rate. And the present value, I'm going to borrow 100,000, and that's into me. You know, they're giving me the cash, so I'll make that because I'm borrowing, so I'm going to make that 100,000 positive. And it's going to be 0 future value because I want the loan to be paid off. And so what are my monthly payments going to be? I'm going to compute the payment, and the payment is going to be 733.76 a month. Not too bad. 8% interest is pretty high. So I'm borrowing 100,000 for 30 years, 8% interest. I got to pay back $733.76. And that's my last slide for this LOS. It's been a very long LOS, but hopefully you've got some calculator tips and tricks from this. But the very last message that I have to give you is called practice, practice, practice. Speed is a skill. Skill gets rewarded. The quicker you get on the calculator, it's just the better. It's just better for you in the long run. It's better on level 1, better in level 2 especially, and in level 3. Speed is a skill. Skill gets rewarded. Speed on the calculator is a skill. And how do we increase any skill? It's through practice, practice, practice. Do as many practice problems as possible. And, fool me once, shame on you. Fool me twice, shame on me. You'll start to see the same little types of questions, the same little types of tricks. So with that, good luck, and we'll see you with the next LOS.